So next lecture is in network theorems. Next lecture is the maximum power transfer theorem. This is a very important theorem for electrical engineering students. What actually the statement says? Maximum power transfer theorem. So maximum power transfer theorem. Maximum power transfer theorem says that it's a very simple when load resistance is equal to when source resistance equal to load resistance, right? When source resistance equal to load resistance, what happened? The maximum power is transferred. Maximum. So when source resistance equal to load resistance, maximum power is transferred from source to load. Transferred from source to load. Right. So when maximum power is transferred when load resistance is equal to source resistance. So if source resistance is not equal to load resistance, so what happened? Maximum power will not be transferred to the load. So we always interested to transfer maximum power from source to the load. We see the circuit diagram here. This is the Vs. This is the Vs. And this is the source resistance. Rs is the source resistance. Okay. Rs is the source resistance. And of course, this is the terminal A and B. And I have connected a load here. This is a load. So that has a RL. So what are the Vs here? Vs is equal to applied voltage or applied voltage or source voltage. Okay. And that's volts, and Rs is source resistance. RL is equal to load resistance. RL is equal to load resistance. So statement you should remember. So when maximum power is transferred from source to load, okay, when source resistance is equal to Rs is equal to RL. This is the condition to transfer maximum power from source to load. Of course, when there is a voltage source, then of course there is a current also in the circuit, right? So what is the current here now? What is the current here inside the circuit? So I is equal to V by R. I is equal to V by R. V is by R. R means here Rs plus RL. This is the I. So then what is the power delivered to the load RL? What is the power delivered to the load? So power delivered to the load RL is, so what is the formula? So that is RL is P is equal to I square into R. P is equal to I square into R. So you know this is the equation 1 and this is the equation 2. Now we substitute I value in equation 2. So when you substitute in equation 2 the I value, so I is equal to what? Vs by Rs plus RL. This is what happened, the whole square. So into RL. This is the RL. This is the RL. So now what are we going to do? To find the condition or to find the RL, and what we do to determine the value of RL. So what I'm going to do that for maximum for maximum power to be transferred, maximum power to be transferred, here also maximum power to be transferred to the load, what do we set first derivative of the above equation with respect to RL, that is dp by dl drl is equal to 0. What we do is simply to find the condition, what I'm going to do, I'm just differentiating. So your p with respect to RL and then differentiate it, and then you make equal to 0, right? So that is then you will get the condition. So what I'm going to do now, so now it's very clear. So I just make a line here. So what I do to find the condition, R is a P and going to differentiate with respect to load resistance and just simply put equal to 0. Now you differentiate it. After differentiating, what you get? So what is your dp? So RL, your P is what? Your P is V square, Vs square by, okay, then Rs plus RL whole square into RL is equal to 0. Right. Now you apply the UV formula. When you apply the U by V formula, so you know that's the formula. So first I am going to make it this and I'll differentiate this one. So when you differentiate, see this is a whole term is a, this is the one term. This is a V and this is a U term. Right. Okay. So that's how I am going to differentiate. So now when you differentiate it, so what you will get? Actually you are differentiating with respect to, this is the RL we are going to differentiate. So then when you differentiate it, what happens? This will be 2 into Rs plus RL, right? Rs plus RL, right? Then what happened again? Okay, now when you are going to apply this UV formula, just have made a little mistake here. So what you have to do, see this one you are differentiating with respect to L, right? So then this V square will be a constant, so that will be coming outside, that will be coming in the outside. So you only differentiating RL, so RL by Rs plus RL, so whole square, okay, is equal to 0. Now Vs square is equal to, so now what is the first, we have to take this one, Rs plus RL whole square, and differentiate this one, RL by RL, it will become 1. So next RL be a constant. Now, okay, now we are going to differentiate this one. So what happened? 2 into Rs plus R, okay, by, so you have Rs plus RL whole square. Already square is there, so it become whole power 4 is equal to 0. Now what happened here? Vs, when you take downside, Vs become 0. This become, you take it down 0. Now what is the common here? Rs by RL is the common. So when you take Rs by RL, so what happened? So 1 Rs by RL, okay, minus here also Rs by RL is there. So what happened? This is a 2 RL, okay, then 0 divided by R square plus RL whole power 4, after taking common 1 Rs plus RL, then you will get Rs plus RL whole power cubed. When you cross multiply, you will get, obviously you will get this equation. Right. Now RS is equal to, what is the plus RL minus RL? So that is a minus RL is equal to 0. So RS is equal to RL. So this is the condition you want to derive. So when maximum power is transferred, when source resistance is equal to load resistance, then maximum power is transferred from source to load. And also we see that this diagram. So you can see that this one is the graph. You should remember this one is the load resistance and this one is the power. Y-axis is the power. So maximum power when it is transferred. So maximum power is transferred. This is the P maximum when your source resistance is equal to load resistance. So then maximum power is transferred. So this is a very important theorem and you should remember. So in most of the electrical engineering, this formula is very important.